All right, we're going to get this party started here. Now I should, okay. All right, well, I want to thank you all for coming out again. And I'm seeing a lot of familiar faces. That's a good thing. We're getting people coming out here more than once. And this obviously is our Hacker Dojo AI lecture series. And today we have Vishnu Hari from Accenture. And I guess he's going to be talking on chatbots. He might go off script there a little bit. If you guys are really, is anyone here going, hey, I have to see something on chatbots? Does anyone raise their hand? Anybody is, okay, good. So he's going to go off script a little bit and maybe do a little bit of different stuff, tell us a few stories about his experiences. And let's see now. We do have a little time before we want to get going. Now, I know we have one person who wants to make an announcement. I want anyone out here, if you guys want to make some kind of an announcement of some kind, or just even come up here and tell us who you are and why you're here, that'd be great. We'd be glad to have you. Let me see now. Anybody out there got something they want? Hey, absolutely, come on up. See if I can get your name. It is Michael. All right, Michael, I'll let you have the mic there.
So on December 4th, the IEEE Consumer Electronics Society and Signal Processing Society is going to be doing a talk on the differences in sensor technology between drones and autonomous vehicles. So I'll be giving the talk if you guys are interested. December 4th, it's held over at NVIDIA. I think there's a $5 charge, but you get pizza with it. So
that's interesting. So that was the differences between autonomous drones, the differences in the actual apparatus that they use, or?
So the sensor technology and some of the autonomy. So with the Uber has Uber Elevate, and they're doing Uber Eats with drones, and then people are looking at replacing some of the lines that FedEx might do with drones.
Oh yeah.
So instead of weight is very important, so they want to get rid of the pilots in a lot of these, make them fully autonomous. So when you go fully autonomous inside of an airplane, how is that going to change on the sensor technology? We've got to see objects that are a lot farther out. That's a lot different than
interesting.
Communication differences are there. It typically is an Eventbrite.
And where was the location again?
So if you go to the IEEE Consumer Electronics Society, there will be links from there. So IEEE, Silicon Valley, Consumer Electronics Society.
And
there will be a link.
I think you said, was it next Friday or something like that?
December 4th.
December 4th. Fantastic. All right. Okay. And Gloria, I think you wanted to say stuff. This is Gloria.
I'm not prepared, but my name's Gloria DeFelix, and I'm around here at the Hacker Dojo pretty regularly. But I've been doing a series of machine learning workshops that I highly recommend. I've learned so much, from scratch, and I'm very familiar now when we have these lectures. I'm tuning in very quickly because I understand all the code underneath it. Anyway, it's called hands-on machine learning, and most of the workshops take place in San Jose. There's a handful of workshops happening right now in Fremont. This weekend, it's Python for data science, and we actually go through a machine learning problem, step by step, the code. And then the weekend after that, there is a intro to machine learning, and then advanced machine learning, and then intro to neural networks, and then advanced neural networks. So if you guys are at all interested, just let me know, and I can tell you who I've been learning a lot of this information from, and I highly recommend. Thanks.
So just to repeat, if you are interested, just talk to Gloria after this event right here. And let me see now. I see someone come in with drinks. They're not coming here, though. Okay. I'm going to go ahead and bring in V.S. Joshi. V.S. Joshi is the person who brings in our speakers. And he's prepared a presentation to get us started on this. So V.S., I'll let you take over. There you go.
Hey everybody, my name is VS Joshi. Okay, so actually today is a very sad day here at Hacker Dojo. We came to know something today morning. In fact, it happened last night. The whole Hacker Dojo, all 100 members, we had done a lottery pool for the Mega Million, and we didn't win a single thing. I think we won $2. We won $2. But anyway, so I think if you see this lack of energy amongst all the Hacker Dojo members, you can imagine it's all because we were all hoping for that $1.6 billion, and we had made plans and things like that. We had also decided that the money will go to Hacker Dojo first because Hacker Dojo is a non-profit, so we won't get taxed. So our plans, everything was, up to everything, all the I's were dotted, T's were crossed, everything was done. It's just unfortunate that somebody from South Carolina won it. I was telling Ed, go to South Carolina, get the ticket, but he didn't listen to me, so it's all his fault, yeah? But anyway, so I hope you understand that people are now in a down mood anyway. Anyway, I think, how many people are brand new to Hacker Dojo right now? Okay. Wow, okay, I see 7, 8 people over here. So just to give you a quick introduction, before I give a quick introduction, this is an AI lecture series. And in the AI lecture series, we had 11 lectures. And in the 11 lectures that we had, each and every lecture is supposed to be an independent lecture. Each and every lecture was supposed to be given by speakers for, each and every lecture was supposed to be given for people who are beginners, people who have never known anything about the subject. Hold on, I think Ed is trying to say something. Ed, what's that? Tap the tracker? This thing? On the laptop, what is it? I don't know. He wants to break the loop, he says, okay. Yeah, I think he just did. Is it broken now? Okay, good enough. Okay, no problem. Okay, so this AI lecture series, it's, again, it's, okay, what is this? What happened here? Okay, yeah, okay, good enough, okay, no problem, okay.
You gotta speak faster.
Okay, that's okay, that's fine. So again, I think each and every lecture is supposed to be a brand new lecture. It is an independent lecture. We are still having 3 more lectures to, oh goodness. We are having 3 more lectures, and those 3 lectures will be essentially delivered over the next 3 Wednesdays, okay? Okay, it's okay, don't worry. But anyway, so for all those people who are new to Hacker Dojo is many things to many people. It is a co-working space where we have almost like 300 members, and out of the 300 members, 100 members, they are just here because they like this whole feeling of technology-related community and things like that. So we have a co-working space. There are many companies, startups who are over here. Generally, what happens is when you are a new startup, just 1 or 2 people, or maybe up to 8 people, people will just gather around the desk and they will hack the ideas over here. They will kind of work on their ideas. And once generally people have 8 or more people in the team, then they graduate out of Hacker Dojo and they have their own space and things like that. So there are like almost 2,500 to 3,000 startups that have gone through the doors of Hacker Dojo. Some of the famous startups are Pinterest and Pebble. These startups started over here at Hacker Dojo, and then once again, so it's a co-working space. Entrepreneurs, wannabe entrepreneurs, they come over here. Even if your main office is in New York or Boston, you can come over here and you can work from Hacker Dojo. So that's what is a co-working space. It's also a maker space. So over there we have 3D printers, we have the soldering gun, there we have the laser cutting machine. Yeah? Sure. There we have the laser cutting machine and things like that. In addition to that, this is also an event space. And by that, what I mean is we have something like 5,000 events have happened over here, and all kinds of events, coding camp, we have this lightning series, and for kids also, we have some technical camp for kids. There's a yoga camp, there's a meditation camp, all various kind of camps happen over here. Sometimes we have a lot of meetups over here, IoT meetups, blockchain meetups, and all those kind of things. And in addition to that, it is also a learning space. And by that, what we mean is, again, this AI lecture series, all these speakers from all top-notch companies like Accenture, IBM, Amazon, and Microsoft, they have all come over here with a very noble thought of democratizing AI, of demystifying AI for beginners. And for all these things, neither have they charged us anything, nor do we charge you anything. It's just a learning space where people can come and learn about various things, okay? So I think, so that's what Hacker Dojo is in short. If in case you have any more questions, Ed is the executive director. You can ask him. You can contact me also if in case you want any more questions. Okay, so I think, okay. Okay, this time I was not the problem, because usually I am the reason why it kind of fails, but this time I didn't even touch it. You saw that, right? I was, as it is, I was very sad that I didn't win something, and you know, he picked the ticket. I didn't pick the ticket. I told him to go to South Carolina and things like that, but he never listens to me. Yeah? Believe me, we had some great plans. In fact, we had decided, you know, if we win it, we'll give you a call to the guest speaker and we'll tell him, hey, Vishnu, just go there to the Hacker Dojo, get yourself arranged, and yeah, people are friendly people, just introduce yourself. We had all the plans, you know. It's getting there, it's getting there. Okay, no problem. Okay. Okay, I will use my clicker. Okay, anyway, so I think now what is, okay, perfect. Okay, thank you very much. Okay, you got into it. Okay, so I think when I was speaking with Vishnu, he mentioned there is an absolutely hot topic that is going on, and I think I'll come to that later. And so he wanted to cover that topic, and I said, okay, this is like a bonus for our audience member and things like that. So I said, okay, if that is the case, I can start off with the virtual assistant. That is our topic for the day. So I'm going to start with virtual assistant. I'm going to give you a very high level. I think most of you would know about virtual assistant and voice assistants and chatbots, but I'll just give it a start, and then Vishnu Hari will take over from there, and then he will also go to his bonus topic, which is the hot topic in the industry, okay? So that is going to be the agenda. So when we think about virtual assistant, think of there are two kinds of virtual assistant. One is the voice-based assistant, and there's a text-based assistant, yeah? When it comes to voice-based assistant, I mean, yes, they are called the voice assistant, and yes, you all know the various voice assistants that we have. And usually what is happening in a voice assistant is the delivery mechanism. The delivery mechanism that the voice assistant use is different. Like, let's say, for example, you have a smartphone. You know, it's you have Siri. Siri is using smartphone as a device, as a mechanism to deliver that the voice assistant. At my home, I have this Xfinity Comcast, and with Xfinity Comcast, I have this smart remote. So I just, I mean, from my, so I think there is where I kind of, you know, I want to watch so-and-so movie on Netflix. Again, it is a voice assistant that is helping me, so that is a smart remote that I have. And then again, I think we also have smart speakers, Alexa and things like that. They have taken over the market for smart speakers, yeah? So all these, like in cars also, you have these smart cars where you can give commands and things like that. So they all come under the broad category of voice assistant. And yes, they are all virtual assistant, yeah? And then what we have are the chatbots. Chatbots, they are essentially the text-based assistant. And within chatbots, you will have the SMS chatbots, you will have the website chatbot, you will have the messaging chatbots, you will have the email bots and things like that. So again, all these things are essentially delivery mechanisms for voice assistant, and they are the delivery mechanism for the chatbots. Again, for chatbots, as I mentioned, websites, SMS, messaging apps, it is through those mechanisms, it is through those vehicles that you get that functionality of chatbot, yeah? Which is through iPhone and Android phones, smartphones, and smart remotes, you get the voice assistant functionality. Okay? Again, as you all know, these are the top three voice assistants. And again, does anybody know which company is this? What is this particular voice assistant on the fifth one? Yes, it is. It is. Okay. Hey, it was not meant for you. You're supposed to. Bixby. Yeah. So this is Microsoft. So again, that is Microsoft's Cortana, and this is Samsung Bixby. Yeah. So again, I think if you, yeah, I think if you look at this, again, if you are the product manager, for any of these products, you are thinking in terms of three different axes of competition, of three different vectors. You're thinking on three different vectors. Yes, of course, you're thinking about the technology part of it. Okay, what is the quality of the speaker? What is the quality of the microphone? How much processing power have you packed into that virtual assistant? What's up?
I was looking for the clicker.
Yeah, it's so, yeah.
Oh, okay.
Okay. Yeah. So how much computing power have you packed in these speakers? How is the NLP? What are the actions that can be taken by these things? You're looking, especially you're looking from the technology vector, but you are also looking from a network effect. In the network effect, by that what I mean is, what has been the user adoption of your voice assistant? Because if the user adoption is great, then the developers are going to come and build skills for your voice assistant. So you have Alexa. Alexa has a humongous user adoption, and because of that, you will have like 50,000 or so Alexa skills. So the user adoption drives the developer interest and the developer apps and the developer skills. They again drive the user acquisition and things like that. So it's a kind of a circle that goes on. So this network effect, again, the network effect can also come by, is your voice assistant connected with the appliances in your house? Is it connected with the light? Is it connected with the refrigerator, with the washing machine, and those kind of things? So that is one thing. And in addition to that, there is also this data network effect. In the sense, okay, if you started getting this data, if the data is there, then it becomes very difficult for you to switch to your competitor. Yeah? So in addition to the technology effect, there is also a network effect, and there is also an embedded effect. So if you are the product manager for any of these products, you are thinking on those lines, okay, how am I doing as far as the technology is concerned with the other vendors? How am I doing as far as creating that network effect? How am I doing as far as embedded effect is concerned? Is my voice assistant embedded with the day-to-day workings and the day-to-day workflows? For example, Google and Siri is very much integrated into our day-to-day things. It is integrated into our smartphones and things like that. Amazon is trying extremely hard. They have a lead in that smart speaker market, and they're trying extremely hard to ensure that they keep the lead over there. Because once you are embedded into people's lives, you are embedded into people's workflows, it is very difficult for the consumer, for the user to move away from your voice assistant to something else. And if you look at this, this is the market share. This is the market share of all these 5 vendors. Again, these, you'll see Apple Siri, of course, because yes, we are all using Apple, we are all using iPhones and things like that. So yes, our Apple Siri has 45.6% market share. And you know, every player holds a specific advantage. If you look at like Apple Siri's quality is not supposed to be that good. But Apple Siri is embedded extremely well into the iPhone that we are using. It is embedded into the hardware. Google, okay Google, it is kind of, it has the power of that Google search engine behind it. If you think of it, voice assistant, you keep on asking, okay, what is the height of the Empire State Building? What is the height of Eiffel Tower? How much is the distance from here to New York? These are the questions you are asking to the voice assistant. And Google, because of its inherent advantage, because of its Google search, because of its Google Maps and things like that, they have a certain advantage. And every vendor has an advantage like this. Microsoft, believe me or not, Microsoft has Cortana, and Cortana is integrated into your Windows 10. And it is there on many, many installations. You may already have it, but you may not even know it. Sorry, go ahead. Sorry? This is the market share. This is the market share. Yes. So this is the percentage of the market share. And again, what I'm trying to say is each and every of these vendor, they have certain advantage. Like let's say, for example, Microsoft, like Windows 10, Microsoft Windows is on each and every desktop, each and every laptop. And they have integrated their Cortana voice assistant in each and every desktop. And we don't know because we are not using it, maybe. But that is how they are getting. I mean, I was myself surprised to see that they have even 5% of the market share, because we keep on hearing about only the top 3, Apple, Google, and Amazon. Like Amazon is number 3 over here, But in the smart speaker market, they are #1 by a huge margin. But when you calculate Apple Siri, how many people we have Apple, everybody is using iPhone over here, you realize, okay, that is the reason why you have this high percentage for these kind of, for these various players, yeah? Samsung Bixby. The biggest advantage that they have is Samsung Galaxy phone. Samsung is the largest manufacturer of smartphones. And Samsung has a product Bixby. Now, Bixby is integrated very well into the whole Samsung ecosystem. So the context awareness that Bixby has, very few voice assistants have that. Because Bixby, because it has access to the apps that are there on the Samsung phone, on the Galaxy phone, they can understand the user activities and they can provide certain features which are personalized features. So that is the advantage that they have. Not only that, Samsung, the largest TV manufacturer, again, using Bixby, they can manage their TV, refrigerator and washing machine and dishwasher and everything. All these are the hardware that Samsung has. These are the assets that Samsung has, and that is Samsung's play. Samsung is brand new over here. I mean, Alexa was, again, I think Samsung is brand like they started 1 or 2 years back, I guess. So, but that is the advantage that they are trying to play with. And each and every vendor over here, they are racing to build their position. They have a certain advantage and they are trying to figure out how can I use my advantage to get into something else, yeah? Right now, as I mentioned, Microsoft is integrated very well with the Windows 10 desktop and laptop. But Alexa has launched Alexa for Windows 10. That is going to kill Microsoft's, whatever little advantage Microsoft has. And Microsoft, in turn, is trying to get Cortana onto iOS and Android and things like that. And each and every company is trying to fight for that. This is a huge battle. I mean, we may not realize this thing. If you're not working directly in these companies, we may not realize this thing. But there is a tremendous battle that is going on between these vendors to get that leadership spot. And why is it important? Why is it important for them to get the leadership spot? Because if the winner of the virtual assistant or the voice assistant marketplace, they are going to control the platform from where users access information. Yeah? We have, again, here, and it is very important, because I'll give you an example. Like my parents, they still struggle with giving me a WhatsApp call. The phone and mute button, this, that, and believe me, they just can't do it. For them to have something like this, Alexa, call my son, make a video call to my son, they would do that. That's not a problem for them. And yes, there are like 4 billion people who don't even have access to internet. And yeah, for them, this becomes an important thing. That is the reason why there is a race that is going on between these vendors. My daughter, she slays Alexa like nobody's business. Alexa, play this. Alexa, play that. Alexa, what is... The other day she was saying, Alexa, how much is 2 multiplied by 3? I said, wow. So these are the kind of... here is an older generation trying to get onto these things, and here's a younger generation who's trying to use these things. So that is the reason why it becomes very important, and there's a battle that is going on, is tremendous. You must have seen this battle during the browser time. In the browser, you'll see this is the lots of browsers, and finally now we have come to a stage where Google Chrome has 66% of the market share. Again, it started with Netscape Navigator, right? Netscape Navigator in 95 or something like that, and they were the leader. And then Microsoft came from behind with their Internet Explorer. And what Microsoft did was they integrated their Internet Explorer into the operating system. And they bundled it there that way. And lo and behold, Netscape was completely gone. And by 2002, Microsoft Internet Explorer had 95% of the market share. And at that time, Chrome was not even there. And Chrome comes much later, and now we are in a situation where Chrome has 66% of the market share. Netscape's finally evolved into, they gave it to the open source Mozilla, and then they have come up with Mozilla Firefox. Microsoft Internet Explorer, from 95% of the market share from the beginning of the century, they've fallen down to 7% of the market share. Again, having control of that portal that will give access to information for your users is very critical. And this is what the fight was going on. And this was the browser battle of yesteryears. And then we had the search engine battles. This is what happened in the search engine battle. In the search engine battle, Google, just took over 92%. I can guarantee you that there are at least, if I ask, other than these search engines, have you personally used any other search engines? Sorry? This is the world. Oh, okay, then it might, okay, I took this thing from the stat counter global stats. So I think maybe you're right then. Okay, maybe it is, but Baidu, I written Baidu over here. All of China is Baidu. Yeah? No? Okay. Go and sue these guys, man. Okay, I took it from them, okay? Okay. Just curious. Yeah, no, but again, so this is, again, do you remember any other search engines? Anybody over here? What are the other search engines that you have used other than these ones? Okay, DuckDuckGo is one. That is a new one, actually. But, sorry? Yes, Ask Jeeves, Alta Vista, Lycos, Excite. I have used this. I have used all these search engines, and all of them are gone. And now we are finally over here to this Google with 92%. And Murli is going to check whether this is US numbers or the other numbers, okay? Same thing, another battle for the mobile operating system, right? Again, Google Android took 77% of the market share, Apple iOS 21%, others only 2%, okay? Again, this battle is, they're fighting this battle. Now, if you look at all these three numbers that I showed you, everywhere Google is the leader. Mobile operating system, search engine, browser, okay? Now you come to the smart speaker market. You have Amazon Echo as the leader by 70% or so, yeah? Google Home, 24%. And Amazon is striving very hard to keep this lead. Amazon started much earlier. They started in 2014. Google came into picture in 2016. After that came into picture, Amazon had a version which was a economy version. I think it was called Eco Dot, I guess. The first one was Eco in 2014, then it was Eco Dot. And then finally they have come up with something called Eco Show, which is essentially has a video capability. And similarly, Google has also gone from Google Home to Mini Home to Google HomePod. And Apple launched sometime at the beginning of the year, they launched their it is HOME, HomePod, okay? They launched the HomePad at the beginning of the year. And yes, this is the market share amongst these various players, okay? And you won't believe this thing. I mean, okay, anybody can make a guess how many people are working on Alexa, at Amazon Alexa. Again, Amazon is trying very hard to keep this lead because they know this is their access to the marketplace. This is the control that they want to have. Amazon has 6,000 people working on Alexa. Just for a moment, think about it, right? These people are research engineers, whatever it is. They are working on Alexa. The 6,000 people are working, yes, engineers and things like that. Yeah, that they pay. Think of it. The average salary, the total added cost of each employee is, let's say, $200,000. $200,000 multiplied by 6,000, 1.2 billion. Amazon is spending 1.2 billion every year so that they can keep this lead of 74%. Because this is what is going to lead to the network effect. It is going to lead to the embedded effect and things like that. And yes, they can control the portal which will give access to the information. They have 50,000 skills. Alexa has 50,000 skills as compared to just only a few thousand from Cortana and things like that. Yeah. Today, this is from Verge. I think this is just from last month. Nearly a quarter of the US households own a smart speaker. That is almost 24 million. 24 million households have a smart speaker. That means it's almost like 50 million adults. They have access to smart speakers. We are taking an average of 2 people per household. And yes, okay, 50 million people have access to the smart speaker at this point in time. Okay? But again, so we are going to go into a world where within the next 10, 20 years, each and every one of us is going to have a speaker, a voice assistant and things like that. And I just want to show you this particular clip. And again, it's, we are going to go through a lot of painful process also, by the way, yeah? Oh. What happened here? tracker. Calendar.
No meetings today. Remember, communicate at 9:30.
Fire off.
Fire
Open door.
door open.
Fire. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open door.
Repeat that.
Open door.
I didn't understand that.
Hey, open door.
Play on the phone.
Again, we are all going to go into this, which are not very soon though, yeah? Anyway, so this was, again, this is all about, again, the first slide I showed was, yes, we have this virtual assistant, and virtual assistant, we have the voice-based and the text-based. So we talked so far was about the voice-based assistant, and now the text-based assistant, okay? Essentially, so text-based, it's all chatbots, and as you can see, chatbot is essentially a service. It's a service that is powered by rules and AI, and users interact with this chatbot via a chat interface. So think of them, they are just digital users. Imagine that they are users on the other side, but they are digital users, they are not human beings. They are digital users, they are software, they are powered by software, they are not powered by human beings. And again, here we have SMS chatbots, website chatbots, messaging chatbots. You have all of you have already dealt with this thing. I'm 100% sure. And again, if in case you haven't, or maybe I'll just show you a screenshot and then you will realize, oh my God, I get this so many times, yeah? This is a website chatbot, yeah? And the website chatbot, I was trying to change the date of one of our speakers, so I went to the Eventbrite, and then this is the screen I got, okay? How would you like to interact with us? Okay, Help Center was essentially FAQ, or email, but it will take 1 day. Chat less than 1 minute, and phone 1 to 2 minutes. They'll keep me on hold and things like that. So of course I selected chat. And then a window pops up, which saying, okay, put my name and everything. And then now I'm chatting with that person. So that is basically a website-based chatbot. Okay, if you go on Macy's.com, you will get a website-based chatbot. My bank has a website-based chatbot. So it asks me, okay, hey, what do you want to do? I want to pay a bill. Okay, it does all those things. It's a digital user on the other side. It's not a human being, it's a digital user. And because of machine learning and AI, it understands certain things that I want to do and certain things I would like to get done, okay? This is an SMS chatbot. I go to Apple Store, and I have, as soon as I go there, I give them my phone number, and lo and behold, I keep on getting these messages from them, okay, hey, you haven't checked in. And I said, hey, I've already checked in. Again, I'm literally getting angry with this, but I have to realize that, gee, I'm talking to a chatbot at that point in time. Nobody is sitting over there and typing all these things. It's just that the moment I put in, so this is again an SMS-based chatbot, okay? Messaging apps. These are the leading messaging apps that are out over there. I somehow don't belong to the generation which is on messaging apps, but wow, I mean, I was kind of surprised to know that lot of communication, more communication happens on messaging apps than happens on social networks, yeah? Messaging apps have a huge user base. The monthly average user on messaging is more than that on social networks. And yes, if people are going to be on these messaging apps, then businesses need a way to interact with their customers, right? If you are going to be on WhatsApp, or if you're going to be on Facebook Messenger, or if you're going to be on Slack, or you're going to be on Skype, businesses are trying to figure out if you are there, they don't want you to go to their website and interact with them. Can you go on Skype and just say, hey, I would like to know what is happening, where is the closest Macy? You do it from the messaging app itself, right? So there are these messaging apps, and within the messaging apps, they are trying to create chatbots within the messaging apps, okay? Why? Why do you need chatbots in a messaging apps? Okay? Because, you know, if you go to an app, you essentially need to download the app. And then, okay, there's a whole process to download the app and all those kind of things. But when you are on a messaging platform, you just have to type the question. Hey, where is the closest California Pizza Kitchen? On that messaging app. And yes, the bot will answer that question. You don't have to go to California Pizza Kitchen app and this thing, hey, I would like to order a pizza from California Pizza Kitchen. You can do that thing from the Facebook Messenger. And there are a lot of bots that are developed on top of Facebook. Yeah? So again, chatbots through messaging apps, they don't require any installation. Again, they are very easy to build than the apps. Lots of use cases. With apps, there might be 4 or 5 users they might be handling. But with a chatbot, you can have 1,000 questions asked. And yes, the chatbot will answer those 1,000 questions because it has been created that way. Yeah? Again, with the chatbots, you're just essentially using the language. With apps, every app has a different user interface. Nothing is consistent between one app and the second app. So that is a problem with the apps as such as compared to chatbots. Again, I think I was kind of shocked to see this article. It says that chatbots are going to replace mobile apps. They will soon kill the app store. I was absolutely shocked. Sorry. Yeah. I absolutely agree with you, and the reason why I agree with you is because my startup, I had my startup that was built on top of Facebook, and Facebook shut off the APIs. They deprecated the APIs, and the moment that thing happened, my entire value proposition of my startup was lost overnight. So I absolutely understand what you're saying, that yes, if you are trying to build something on the messaging apps, yes, it will give you a channel, but the control is still with them. But I think there are certain startups who are starting chatbots where the data and the control will remain with the companies. So I read it just yesterday. I read it. There is one chatbot startup, and their claim to fame was, okay, you can build your apps on top of the other platforms, but you retain the control and things like that. I didn't get how it was, but I'll share it with you later. Okay. Yes. Yes. Absolutely, absolutely. You know, absolutely right. I mean, again, I have learned it the hard way, that depending upon these big companies for your entire existence is not the right way to go. And there were thousands and thousands of app developers that were affected. And what you suggested is absolutely the right strategy, that yes, kind of, you know, de-risk yourself by not only just get the initial momentum from some place, but once you get the momentum, try to figure out how you can independently be self-sufficient and things like that. So I fully agree with you, yeah. Again, you will see over here, how have you communicated with business in the past 12 months? And this is from the 2018 State of Chatbot report. 15% people said that they have communicated with their customers, with their businesses, users have said that they have communicated 15% with their businesses on chatbots. Why? I mean, again, I'm very comfortable picking up the phone and calling, actually. That is my style. My wife doesn't like that. She is more comfortable sending an email and things like that. I personally am comfortable calling the phone. And I was just wondering, what is the big deal about this chatbot thing, okay? So these were the problems people said that they experience with traditional online experience. The site is extremely hard to navigate. If you go on their website, you don't know what is where and things like that. Each and every website has a different user interface. They will guide you through different places and things like that. I want to have a simple question, but I have to dig that answer through all their 100 pages. But instead of that, I can just ask the chatbot, hey, what is this? Where is this? Where can I find the men's 34 waist jean pant and things like that? And they will immediately show, okay, these are the 5-6 selections that you have. So I don't have to go through the website, and I don't have to go through the where exactly it is and things like that. And the user interface is different. Again, if you call somebody, you're on hold for a long time. So again, these are all the reasons why people are tired of the traditional online experience. And this is the reasoning people give for chatbots. Yeah? So as you can see, the top benefits of chatbots: 24-hour service. 64% people said 24-hour service. Instant responses. Again, that was a response given by 55% people. Answer to simple questions. And bots are faster than downloading apps or loading a website and things like that. You can just be in the messaging app and you can ask a question and with that, I'm going to invite our guest speaker, Vishnu Hari. Now, he has a very interesting background. When he was in Toronto, I guess, he built a chatbot to automate his dating experience. So when it came to dates, I think he kind of had some chatbot by which the chatbot was answering all his all the interested people, and he had a tremendous amount of success with that. So he's going to tell us how we are going to do this thing. Yeah, in addition to that, he also has his master's in mechanical and industrial engineering. Again, and he has done his information engineering and AI from University of Toronto. Again, he has done a course on deep learning at MIT, and he is with Accenture. He is an associate principal at Accenture, and what he brings is essentially, he mentioned to me that the hot topic right now is about model management of machine learning, and that is what he's going to speak on. He's going to talk a little bit about his chatbot experience, but the meat of his talk is going to come from that model management and how the machine learning is happening, something that is a hot topic. So with that, I would like to request Vishnu Hari to come over here.
All right. Yeah, hi guys. There are a couple of reasons I wanted to switch topics, and I think I'll start by giving a little introduction of myself. I didn't actually complete my master's or my PhD. I chose to came out here to the Valley instead. So technically I don't have a master's, though my professor would beg to differ. My undergrad is in astrophysics. Kind of wanted to be a space scientist kind of guy, but I got into machine learning pretty early on in my university career. So I'll give you a little bit of background about that first. My research in my undergrad was around discovering exoplanets. How many of you guys know what exoplanets are? Just a quick, okay, so most of you guys know. Basically, they're planets that could potentially harbor habitable life. And the way we look for these planets is by scanning a figment of the sky, right? So there's a pretty famous project called the Kepler Space Telescope project. I don't know if you guys are familiar with it. We got a large number of data sets from Kepler Space Mission. I think it ran until 2003 or 2004. Now, what presented itself was essentially a giant data problem. So we get all these like fantastic images from Kepler, which is the image of the night sky containing billions of galaxies and hundreds of star clusters and star formations. How do we make sense of all that? How do we find the information that we really need within that? Initially, we had some very basic algorithmic systems, autovetter systems essentially, to look for potential candidate stars that could potentially host candidate planets, right? The idea is that if a star is similar or in some magnitude similar to the size of the sun, there could potentially be a planet, a rocky planet around that, that could potentially harbor habitable life, right? So it was kind of guesswork initially. Everything kind of changed in around 2011, 2012, when a pretty famous group in the University of Toronto, my alma mater, published a study on how you could use GPUs to accelerate deep learning. So that's when I'm going to ask the audience sort of a question, a few questions, I guess. Firstly, how many of you guys are familiar with deep learning and the distinction between deep learning and machine learning and AI? Just a quick show of hands. Cool. So I'm not going to go too much into the details of the distinctions, but the idea behind deep learning is that, to put it very simply, when a machine learning system generates features, well, hold on. How many of you guys are familiar with machine learning as a concept? Okay, so you put in some inputs, you don't explicitly program the system, it get some outputs, right? Part of getting its outputs is generating features. And the job of a machine learning engineer or a data scientist is to generate the highest quality features. Now, deep learning kind of jumps past that and says that we can build a network, a neural network, kind of replicating the processes of the human brain that could let the feature engineering happen within the system itself, right? So the idea is that in deep learning, you don't need to do a lot of feature engineering. It's not necessarily the case, but that was the idea behind it. The problem with deep learning and neural networks is that it was very difficult to generate compute to actually make deep learning viable. And even though backpropagation was a theory that was proposed back in the 90s, it didn't really come to fore until, the compute kind of catched up. And the reason why compute catched up is really interesting. So most machine learning or just general data science projects used to be accelerated on the CPU, right? So one instruction at a time, more or less, right? Maybe you have a couple of cores, but one instruction at a time overall. Everything changed kind of when people realized that we could use GPUs, graphical processing units, to essentially do all the work instead. And the main difference between GPUs and CPUs were that GPUs could parallelize computation. What parallelize means is, let's say that I give one super crazy genius in this audience, maybe VS, a task to do. And it's a very complicated task that you need to split into, and you need to have maybe 5 or 10 different hands to use that task, right? But VS, unfortunately, only has 2 hands, or 2 arms. So he's going to have to do the task with 1 or 2 arms first, and then move on, do the task with 1 or 2 arms again, and so on and so forth. Now, unless he's a Hindu god, it's kind of going to take a lot of time to complete the task. Now, the benefit of GPUs is that I can use the entire audience to complete the task, right? So that's 2 times maybe 80 guys out here, that's 160 hands. It's a huge improvement, right? That was the magical thing that we needed, we as the tech industry needed to make deep learning viable. And that's what GPUs do, to put it very simply. You guys probably already know this, but I thought I'd just speak about it for the sake of it. And that was a really exciting development, and kind of I have my alma mater take credit for that, because the paper that published this study in 2011 was huge, written by Jeffrey Hinton, Alex Krzyzewski, and Ilya Sutskever, whom, by the way, 2 out of 3 of them are currently in the Valley. So yeah, that kind of changed everything, and I got really into deep learning around there. I completed my degree in astrophysics, but a couple of my friends and I decided to try to play our hand at applying deep learning into industry. So we formed a startup where we decided to try to solve the fashion problem using deep learning, essentially trying to create a taste profile for people using deep learning. The idea being that if we could get an understanding of how people dressed, or how people chose to dress, or what kind of clothes they bought, we could potentially build a profile and use that to generate recommendations for them when they enter a mall. And maybe retailers, the aging brick and mortar retailers, could finally have an advantage on the engagement front with customers when they walk into a mall. It's an advantage that they don't have, because Amazon and Zappos and all these other online retailers can engage you very effectively because they know who you are. They know what you put in your shopping cart before, right? So we tried that out. That was back in 2013, 2014. I think the industry was, we had a good idea a little too early, and it didn't really catch on. We sold it off, and I joined IBM Watson for a bit. And in Watson, I led a few interesting projects around natural language processing, and that's when I started really kind of branching out beyond computer vision and beyond deep learning into just general machine learning. Led some projects in the automation of customer support. So this is something where I can talk about just chatbots and voice personalization in general. Some banks in Toronto, well, in Canada, were trying to figure out how to make customer service a lot easier. How many of you hate calling banks? Just like getting on the phone and having them, you have to repeat your social security number like 10 times, and it's ridiculous, right? Wouldn't it be great if you just called them and you could say, hey, I have a credit card fraud problem, and they immediately put you to the customer service agent who has all of your information up on their screen, like, yeah, I'm ready to help you, That's what we try to implement, and actually successfully implement. And the idea behind that was that if you've called the bank a few times before and you have the number you called from and the way you sounded, we could potentially build a model that could predict whether it was really you calling and surface that information to the customer service agent almost immediately. So let's say you call Royal Bank of Canada, not that any of you would, because none of you are Canadians, I'm assuming. If you called RBC and you said, hey, I have a credit card fraud I wanted to report, the voice system would automatically analyze, okay, credit card fraud, bring him to the credit card fraud department. Who is this? The number is this. Is this Vishnu Hari. Well, we have prior data of what Vishnu Hari sounds like. Let's compare it. Yes, 98% confidence it is Vishnu Hari. Surface information immediately in front of the customer service agent. So that made things a lot easier, right? And that's what I see to be an evolution of the chatbot and voice personalization. I personally think, and it's terrible to say this, I personally think chatbots are kind of a temporary phase. I think there's going to be a lot more complication and a lot more potential when you start really using deep learning and machine learning to automate parts of the customer experience. The reason why people started using chatbots is because their customer service lines it was just ridiculous, right? People were waiting for minutes, sometimes hours, to get a hold of a real person, and what companies thought is that they could use a simple rules-based system to automate it, and what resulted was essentially a very, I'd say, depersonalized experience, and that's why chatbots are kind of a little bit fallen out of style, in my opinion, from what I've seen. So a little bit about the Tinder thing. It was a stupid thing. When I was in university and I was a bit of a cheeky guy, I thought, well, why can't I automate? Because look, when you're on, I don't know, how many of you guys have used Tinder or dating apps? You don't have to raise your hand. It's okay. Yeah, I guess so. Especially when you're in college and you want to date people. So what I realized as a guy was that normally men have to initiate these conversations. Very rarely. The only case where it's not happened is actually my current girlfriend. You can kind of tell why she's my current girlfriend. But normally men have to initiate these conversations, right? And when you do initiate the conversation, you have to say something kind of witty. If it's just, hey, and no one's going to listen to you. So what I thought was, okay, well, what if I could build a chatbot that had literally a lot of jokes in its memory, and started the conversation a very specific way every single time that would railroad the person into a certain kind of conversation. So this wasn't an intelligent chatbot by any means. It was a very basic rules-based system, right? So there was nothing intelligent or special about it, really. What it did was it would start by saying, did you swipe for the puppy or the beard? And my profile picture had my little puppy and obviously my beard. So it had a very significant kind of process by which a person would answer it, right? You could either say yes, both, neither, or not respond at all. So based on that response, it would then generate a series of fun jokes and personality questions that everyone has to go through at some point anyway, and it's just a damn song and dance routine. So it was fun. It was great. And every single girl that I met in person did not know it was a chatbot. And surprisingly, I didn't get slapped a single time. So that was cool. So that was my journey with chatbots, and I realized how empty it made me feel, so I stopped using chatbots altogether. Anyway, that's the whole thing about chatbots. I'm going to talk about it anymore. So what happened after IBM was I got an offer to join Accenture as an associate principal in Silicon Valley, and I was really excited to move because Canadian winters are terrible, and the weather here is pretty much perfect, as best as it can get, so I decided to go. And I wear sort of two hats at Accenture. In one hat, I'm kind of a management consultant in the sense that whenever a company needs to figure out whether or not they need machine learning or deep learning, they ask someone like me. So I go in there and try to understand what the business problem is. So I try not to think like an engineer or a data scientist. I try to think like a consultant or a business analyst. What is your business problem? And will machine learning actually help you solve that problem? And I try to take a sort of path of least resistance approach, essentially, where you don't need machine learning a lot of the time, right? Surprisingly, and this is not popular amongst my leadership, but most of the time I'm like, you can just fix that with a simple linear regression, just plot your values on an X and Y, and that's it. That's all the prediction you need. So it's not very often that you actually need something like machine learning or something really heavy duty like deep learning to solve your problem. And my goal is to translate that business problem into a machine learning problem, if that exists. And then that's when I take off my management consultant hat and I put on my sort of data science manager hat, where I go to my team in currently the Salesforce Tower in San Francisco. I go to my team and say, hey, this is the problem they have. This is the kind of system that we need to use. And let's try to build them something in 3 to 4 weeks. And then if we can prove out that there is some value in this, let's make that a longer engagement. So that's sort of the gist of my work, and I've been doing that for about a year now, and it's been really exciting. I've had a lot of interesting projects. Some have been really creepy. Some of the stuff that I've done for governments in Asia around surveillance has been particularly distressing, and I personally left those projects because I was like, this is a little too much. The things that you can do with deep learning on the edge is absolutely insane, and it's definitely a cause for concern, and definitely a cause for us to talk about ethics in artificial intelligence as well. I think it's a really important topic. But that's not what I'm here to talk about today. I'm here to talk about something else entirely. So let me try to figure out how to segue into this topic. So my current role is, yeah, sure. Don't forget your phone, guys. So my current role is at YouTube. My main client is Google, and what I'm currently doing is deep learning on some really cool projects that unfortunately I can't talk about. I really wish I could. But the overarching picture that I've seen in this entire year of being in machine learning at a consulting level across industries is a need for people to manage the data science process and the machine learning workflow. And the reason is a couple of reasons. So back in the early 2000s when software development was becoming a thing and people were actually trying to figure out ways to industrialize and productionize machine learning, just software development, there was this whole idea of Agile. There was a whole idea of GitHub, figuring out how to, and I'm not a software engineer, so I didn't really experience that, but from talking to software engineers, it became a really important thing to figure out how to organize your team and productionize the whole software development process so you could actually ship on time, right? So that was really important back then, and I think the same thing is happening right now with data science and machine learning. As more and more machine learning and data scientists enter the field, there is an increasing need to figure out how to industrialize and productionize not just the data science workflow, but the machine learning engineering workflow. And there's a distinction between the both. There is a huge gulf between what is data science and what is actually scaled machine learning. And I'm going to talk a little bit about that before I get into model management. So a data scientist, generally their background is in doing projects, small scale, most of the time, small scale projects that would involve some sort of scikit-learn models or some really basic Python models, right? They're not really building models in university that's going to extend to scale. It's not like 10 million people are going to have their lives changed if you push out a model, right? That's different when it comes to being a machine learning engineer. When you're a machine learning engineer, you're building out the pipelines to actually help a data scientist scale their model. And I'll give you a good example, right? If you're a data scientist within let's say a small mapping company, your models are going to affect maybe the specific audience you have. Maybe you're building a mapping service for truckers, right? The only thing that you're doing at that point is when you push a new model, the only people it's going to affect is truckers within your system. Pretty small impact. But if you're Uber, every model that you push out is going to have an impact to the millions, right? And Uber has maybe thousands of models in production. So they face that problem early on where I think I'd say back in 2015, 2016, they were wondering, I think even earlier than that, they're wondering how do you firstly unite the different models that different data science teams across Uber are going to be building and deploying? And secondly, how do you monitor and scale that process, right? And that's where they came in with their version of model management, which now today publicly is called Michelangelo. It's their own internal system. Google has had this process too for Maps and several other of their internal products. And there now are companies like Domino Data Labs who are offering this as an actual platform as a service, and now Amazon has come out with SageMaker. So what are all these things? And I'm going to try to sort of keep it as high level as possible and not get too much into the weeds. I hope I'm not losing you guys. Just tell me if I'm being boring, please. So model management is the ability for a company or an industry to industrialize and productionize the entire model management and data science pipeline. This figure isn't mine. It is basically UC Berkeley's, and I apologize for the huge word vomit. This is essentially taken from an internal article I'd published. So the idea is that the industry doesn't have a good way to deal with the many data science and machine learning models that are currently used for very critical business purposes, right? And this isn't necessarily tech companies. Tech companies generally have a good handle or are starting to get a good handle on how to do this. This is just industry. Right, so maybe it's a transportation industry, maybe it's government, maybe it's finance, right? Finance is a great example. The idea is that they need a way to have a system whereby they can monitor and scale every single part of the data science process. And part of that comes from understanding how the data science workflow actually works and how it happens. So normally what happens when you're a data scientist or a machine learning engineer is you figure out firstly what the problem is, like I said, and then you look at the data that you have, right? You explore and try to discover how you're going to collect the data and what parts of that data is actually going to affect your model. And that involves some sort of cleaning, that involves some sort of organization. Sometimes if you're in an enterprise, what you have is a giant data lake and you have to figure out how to ETL that into something that actually makes sense and organize that. So that's the first part of it. Surprisingly, people have this misguided conception that the most important part of machine learning is choosing your model, right? Like, are you going to use, some sort of supervised system like a graded boosted decision tree, Or are you going to use some sort of unsupervised system like k-means clustering to get your predictions? That's actually the least important part. The most important part is the whole pipeline. How are you going to get your data to your model? Once you get your data to your model, how are you going to test that? How are you going to measure precision, recall, area under curve, all these technical terms where you try to figure out how effective your model is? Right? That's the stuff that is actually the hardest part. Well, second hardest part after that is feature engineering, which I'll get into a little later. So the idea here is that models must be trained, compared, and monitored before you actually push it into production. And there are some sort of key, I'm going to skip this part too. There's some sort of key questions that I try to figure out before I actually see if there's a machine learning system or some sort of infrastructural play. I try to ask them where, is there a necessity, firstly, for machine learning? Secondly, if there's a necessity, what kind of data does your corporation or your infrastructure or your business problem have? If you have that kind of data, what are the requirements for you to collect and clean that data? How much time is that going to take? Once you do that, I kind of ask what the infrastructure is that you have for actually building your models around your data. Once you do that, I ask them if your predictions that you're going to generate, do you need that to be real time? Or do you need that to be a batch processed, sort of like every 3 days I need a prediction for X, Y, Z? And I'll give you an example around that. And it's a really important distinction to make, right? So an example around that is if I'm predicting, let's say, ETA for Uber Eats. That's a real-time service, right? There's a lot of real-time elements in that. An example of real-time element is you're building out a model that predicts how busy a restaurant is going to be, right? So that's something that is going to need data validity between the past 3 to 4 hours. So is the restaurant currently at peak time? Are they having hundreds of thousands of orders? Historically, have they had hundreds of orders in this small period of time? If so, how does that affect how long it's going to take for my order to be made? If so, how's that going to affect when I ask my delivery person to actually go out and deliver pick up the food? And if so, how long is that going to take for my deliverer to actually get to the final destination? The final destination piece is actually interesting because that's more historical, right? That's not necessarily as real time. You want to figure out in that period of time, historically, what's traffic been like? But there's also some elements of real time there. Has there been an accident that's happened, right? So you see how there are these tons and tons of models you need to start building out to predict one of these, and then you have to string all those models together to create a final prediction. And that's where a sort of machine learning model management service becomes really, really important. So this is, again, it's just a bunch of word vomit, but the idea behind that is that there is no sort of unified enterprise-ready repository for model review and management. And what I encourage you to think about when you see a problem like this is think about GitHub, right? How dispensable it is, or Jira, or Confluence, or any of those developer DevOps style systems that developers are using today. That currently doesn't really exist at a very high level or a very high quality for data science or machine learning developers. So there's a huge sort of market need for that. So I don't know how many of you guys here are actually founding startups, or just a quick show of hands. Cool. Pretty much I expected quite a few of you. And how many of you guys are currently in industry? Like you're working in a tech company? Cool, cool. And how many of you guys are in schooling? Yeah, for you guys who are schooling, build this. You'll make so much money, no joke. If you can build a system that allows, outside of like Amazon and SageMaker and all this other crap, if you can build a system that can really help data scientists push models to production easier and do it in a really seamless way and have people, data scientists across an organization be able to comment and collaborate on it, that would be the next GitHub, right? There are a lot of projects within Stanford that are trying to do that right now, but they haven't achieved that sort of industry scale yet. So it's a good time to start doing this and thinking about it. And I will take 5% stake in whatever startup. I'm joking. So the key here, and this is published by Domino Data Labs, which has probably one of the better solutions for model management, is that models don't involve code. They aren't software. They aren't your typical thing that just compiles and spits out a very clear value. They use data, but they aren't data assets. They may generate visualizations, but they're not BI dashboards. They are they're something that predicts an output that is not a discrete output necessarily. It's not a yes or no, and you can't really predict what it's going to predict, essentially. And as a result of that, you can't treat models like code because they're inherently probabilistic. And you need to build a system that can manage a probabilistic response. So that's really the key here. So I don't want to keep boring you guys. I'm just going to go through this really quickly. But are any of you guys data scientists? Any? Cool. So if you're building something for a data scientist, or if you're looking to understand what a machine learning engineer or a data scientist really thinks about, what they need to be able to do is when they're building a model, or they're building out even just experimentation around their data, they need to be able to define a workflow. They need to be able to monitor how that workflow is doing. They need to be able to see how their parameters are actually going to be affecting their final prediction. They need to be able to run several experiments, and experimentation is the most important thing, right? And that's really easy to do when you're in college, when you're in your university and running a small project for a paper. It's really easy to do because you have full control, right? And the stakes aren't that high. I mean, they're high for you, but they're not high for anyone else, really. So that's why the infrastructure hasn't really evolved there yet, because classically, in the past 5 years, most data science and machine learning projects have been pretty small scale, with the exception of like Uber and Google. So you want to be able to run several experiments at scale when you're at these kind of companies, and then aggregate those kind of conclusions in a really definable and symbolic way. So when your leadership asks, okay, you're spending like a lot of company compute resources like running this model, why are you doing that? You're like, well, I achieved 5 to 10% better prediction, 5 to 10% better precision because I did that, and that, help your case. Hyperparameter optimization, that's like way too technical for you guys, I'm guessing, so I'm just going to skip that part. But the idea here is that it's just going to make it easier, make your model more efficient, essentially. So debugging is a huge aspect, right? So one of the greatest benefits of something like Git is that it lets other people run your code and debug for you and test for you. And that is such an important part, and I can't emphasize this enough. If your client in the future, or if someone you're selling to is a giant corporation that has data scientists spread out all across the globe, imagine telling them you can harness literally every single data scientist you have in your organization to debug code in the Netherlands, for example. So it's a huge value prop, right? And finally, and I'd say honestly most importantly, is a UI UX system. Some of the projects in Stanford, they're basically command line interfaces, right? You just tinker with some stuff and then you output some results, and that allows you to manage your model. But that's not enough. You need to, if you want a collaboration platform for every single data scientist in your organization, you want some sort of UX or UI for them to be able to collaborate on. So yeah, the business model. So why is this important, right? And I would encourage you to focus on sort of this little bit here, which I shamelessly ripped off from Domino Data Lab's white paper on this. The data scientists themselves need a tool like this because, if you're a data scientist, you normally come to a company with your own tools. And I've had a situation where, for example, trying not to give too many details of this project, but there was a data scientist in Singapore who compiled and ran the entire model in production with his own set of tools. And when he left the company, we had immense difficulty actually recreating and redeploying the system because his Jupyter library was out of date, or his one Python library that he called is deprecated. So even with containerized systems, it was very difficult for us to recreate that, which is why this is, tooling and stuff is such an important thing. And when a company has their own sort of internal platform, most machine learning engineers just don't care about it. They're just going to bring their own sort of tools. So standardization of tool sets is an important reason why this is such an important thing. So there's that. The next thing is tracking the institutional knowledge generated during model development. This is where I go into feature stores and feature engineering. So I'm going to skip ahead a little and get to that. So what is a feature store? How many of you guys know what features are in a machine learning model or have some understanding of that? Okay, cool. So for the benefit of the general audience, I'll sort of talk about that. So I'll use a computer vision example. When a computer vision or a deep learning system tries to understand what it's looking at when it's being trained on a certain set of images, let's say that I'm training a computer vision model to really identify cats really well. And I feed it hundreds of models of cats and I label it as cats. And eventually I wanted to predict cats, right? How does the deep learning model actually generate a prediction? It does that by understanding in its training set what the features were that resulted to a definition of cats being outputted or labels of cats being outputted. So essentially when it looks through these hundreds of thousands of images of cats, it looks for similarities. How does a kid learn what a cat is? When you have a 5-year-old child, and I don't, thankfully, if I had to teach them what a cat was, I'd say, well, look for the snout. Look for little pointy ears. Oh, look, here's a picture of a kitty. That's what a cat looks like. And I'll show him or her hundreds of pictures of cats, and then eventually they'll kind of get a good idea, if they're not stupid like I was, they'll get a good idea of what a cat is. That's kind of how deep learning models work. And the way the deep learning models understand this is through features, right? These high-level systems of like eyes and snouts and whatever that actually, compose what a cat is. Now you can see how that can go wrong, right? Dogs have snouts too, or dogs have ears too, pointy here. So generally, if you train a deep learning system on cats, and you showed a picture of a dog, and it doesn't know what a dog looks like, it'll say that's about 40% cat. And that's generally how a deep learning system outputs a prediction. But the reason why feature stores are really important is because, like let's say I'm going to use an Uber example, right? So Uber has hundreds of, and maybe even thousands of models in production at any given time to output predictions like ETAs, the estimated time of arrival. Let's say that I've built Uber before Uber Eats, and I've built a really good machine learning model that can predict how traffic is going to go between Mission and 24th Street, right? At any given time in San Francisco. Now I'm deciding, my machine learning system has created a bunch of features. It's created, like, some of the features might be time of day. Some of those features might be whether there's an event happening. Some of those features might be other cars on the road. Some of those features might be historical data from that same time in the year, last year. All of these are features that lead to a prediction of an ETA. Now, if I had to recreate Uber Eats, it would be really difficult for me to engineer those features all over again, right? I'd just be spending a lot of time as a data scientist building the exact same model for traffic prediction. What if I could just call those features from a centralized feature bank and say, oh, you guys have figured out traffic? Great. I'm going to take that and I'm going to just put that into my current Uber Eats model, right? So now you've saved your data scientist months of time, and that's really valuable. So companies like Uber and Google and Facebook have realized that feature stores or banks of features are going to be very important to help industrialize and govern how data science and machine learning is done in their companies. So this is the thing that's really important for data science managers, and that's going back to this slide over here. They need to be able to track the knowledge that the institution's generated, right? So when you have machine learning being done at scale at a company like Facebook and stuff, how do you store that information, right? How do you vault up all the high order information that you've generated about the customers and the people using your app? Feature stores are a good way to do that. And any kind of model management system needs to have a feature store. So finally, the last two, which are still kind of important, are the decision makers and the auditors. The decision makers are kind of like your leadership in your company. And that's kind of the people who want to understand the impact your data science model or your machine learning model has had on the bottom line of the company. They're spending so much money to hire machine learning engineers. How do they measure that your models have been successful? How do they measure that your models have actually had a huge impact on the company's bottom line or increased revenue or reduced cost in some way? So a model management system can actually surface that, right? If you can prove that you've cut down delivery times by 10, 15 minutes, that really adds up. If you can prove that you've cut down the amount of time a customer service representative spends talking to their customer to verify their identity, for example, with deep learning, they don't need to do that anymore, that's huge value as well. And that scales across the entire company. The other part that's related to the auditor piece is governance. When you have a machine learning model, let's say that's used to predict whether or not you should apply for a mortgage, you want to be sure that your machine learning model isn't being racist. If historically in the 60s and 70s mortgages were denied to black people, you want to be sure that that's not what your training data is using to figure out whether or not you're credit worthy or mortgage worthy. So that's something that an auditor or a compliance officer will be very interested in, is to understand if your machine learning model's training data was biased. There was an interesting article that was a little inaccurate that was essentially Amazon had some small-scale system where they used a machine learning system to generate a predictor of whether a person who's applying to a role at Amazon was going to be a good fit or not, and had some sort of training data, obviously, that the machine learning system was used to generate this prediction. And obviously, and it's no surprise to anyone who's in the industry, it generated a higher score for male candidates as opposed to female candidates. And if you think about why this happened, it makes sense, right? For these kind of roles, generally, the preponderance of resumes that they would get would be males. And there wouldn't be as much female representation in this. So as a result, the model, without any of the engineers knowing, I guess, generated a higher score of favorability for male candidates. And you can see why this is going to be a problem, right? Obviously, it wasn't just that. There were a lot of other, if you look into the article and why it happened, there's a lot of other features where this machine learning model just sucked at predicting. Yes, go ahead. Yeah. So that's a great question. I don't know how Amazon did it, but if I was a machine learning engineer there and I wasn't very smart, what I would just do is I would just feed in literally all the resumes that had been accepted, right? And that is what it would have caused bias. I wouldn't have even looked at the data. I would have just fed it the successful resumes and the non-successful resumes and said, this is your model. And that's what, yeah. Yeah, possibly it extracted certain features like, yeah, I see. Yeah, so that could be a thing, right? But it wasn't just the gender angle. The system just sucked in general. So on every single measure, the system sucked. And I can see why it sucks, because resumes are not good indicators of whether a candidate's going to be good for a job or not. Really, it's just a piece of paper. How are you supposed to imbue the accomplishments of a person's career on a one-piece page of... Anyway, I have a lot of problems with resumes. I'm not going to address that. Anyway, so clearly that system didn't work. But imagine if they had... I mean, they have SageMaker. I doubt they used it. But if they had some sort of model management system where you could go in and see, okay, this is why the model failed, and these are the points of failure for the model, that would have been really valuable and useful, right? So yeah, so auditing, regulating, regulatory stuff, GDPR, all those things play a huge part why model management is going to be very important in the next 2 to 3 years in machine learning. So this is sort of really valuable for me, and this kind of what I use to figure out whether my client needs machine learning or deep learning or any kind of advanced artificial intelligence system. The first step is to define the business case, right, and translate that into something that's machine learning friendly. Then I try to define what the minimum viable product looks like. You know, is it some sort of simple prediction model? Is it some sort of simple logistic regression model? Or is it something more complex that needs to do some unsupervised learning, which, by the way, I've never done because no client has ever needed it. And then I have to get into what the metrics are for success. How do you define success for this, right? Is success something like decreases the amount of time it takes for a customer service representative to deal with a client? That's a good metric of success, right? And then I figure out what the roadmap is going to be with my team. Like, what is the path to actually implementing this machine learning system, and how long is it going to take, and what are the, you know, OKRs around that, objective key results. So the next thing I would do is then look into the data that the client has. What is the data? Do they even have data in the first place to train this model? And if so, how much cleaning is necessary? So how much pre-processing, how much prepping I need to actually be able to build my model and extract my features. Then I look to see with my team what those models, what kind of models we're going to use, right? Like maybe we just need a very simple model, so we don't have to use a lot of compute. So that's another important step. And then the scaling comes, and then the production comes. And then there's a very important part of it where you retrain your models, right? So generally when you get your data, what a data scientist or machine learning engineer would do is partition their data into 3 very important sets, and this is really important. They partition it into a training set, which is the data that you use to train your model. Then you partition it into a cross-evaluation set. That is what you would use to cross-validation set. That's what you use to validate that your model's working and optimize your model towards that. And then finally use a test set. And that you only use once to see if your model actually generalizes to results it's never seen before. And that's how you retrain and see if your model needs more work. And then finally, you make predictions, and whether you do it offline or online, that really depends on your client and your use case. And you monitor your predictions, and then you figure out the insights. All that other stuff is just your bog standard data science stuff. So that's generally the process that I would use. And that's pretty much a sort of large-scale picture of how model management and data science works at scale. And that's really, honestly, what I wanted to talk about. All this other stuff is like super, you know, crazy technical, so I'm not really going to get into it. But the idea is that you want to have some sort of UI UX system, right, where you can do this easily, and clients can do this easily. So yeah, that's pretty much the summation of my talk, because I don't really want to go into the real details of it, because I don't think it's going to be valuable for you guys or anyone, honestly, at this stage, because everything is still so nascent. But I wanted to take this time to sort of answer questions, and it doesn't have to be about model management. I don't even know if you found this valuable in the first place. Maybe chatbots were a better topic, but you know, I just want to know what you guys think, you know, about this stuff, and whether you have any questions. I'm free to answer any of them. No, I didn't. That would have been really unethical for me to sell a dating chatbot. I think matches around the world would be very upset if they found that they were talking to robots. Although I do think it's going to happen in the future, where essentially you, maybe 20 years down the line, kind of like how my Indian parents actually want to matchmake for me, maybe the chatbot's going to be the one matchmaking for you because they know everything about you. Who knows? That'll be pretty funny. But no, I didn't really. Yes. Yeah. Yeah, so my official title is associate principal, but even I don't know what that means. You're in associate principal of AI. Yeah, I don't know what that means, frankly. When they gave it to me, I'm like, wow, it sounds really fancy. I guess so, yeah. It was a really fancy title, but my real work is essentially, yeah, I work with pretty large companies, not small ones at all. Like my current client is Google, and that's where I am pretty much every single day. And previously I worked with large governments. I've worked with, so far every single company I've worked with at Accenture has been tech companies in the Bay Area, obviously, who want to understand how to use deep learning. And there are companies who still use deep learning who don't know how to use deep learning at scale, right? So that's the kind of work that I do. Yes, at the back. Yeah. Gotcha. Okay, so the question is like risk of using a feature store when you are a large company or a small company, and the risk of dependency, right? So that's a great question, and it remains to be seen. But so far, what I've seen is people use only a portion of the feature store, right? You don't use all the features. You use it to speed up your process, not and augment it, but not necessarily replace it. You still need to do feature engineering, and I don't think it's a good idea for any team to rely entirely on a feature store because it's not going to generalize to their problem, right? And feature stores get better with the more experiments you do and the more machine learning you do in your organization. And it doesn't have to be some sort of public system, right? I don't know of any public feature stores. I see feature store as more of something that you do within your organization and you keep it within your organization. It's not something that I think a public ML cloud like Azure or whatever is going to offer really. Maybe weather stuff perhaps, but that's about it. Sorry, what? Yeah, so that's the SageMaker stuff, right? They're trying to, yeah. Yeah, so I think I think the key point is use it, but use it only for things that are so simple that you're just gonna. It's like calling a library in Python, right? You're only gonna use it if it's just gonna save you a lot of time, and it's a very low level thing you're doing. Like it's calling in NumPy, for example. You just do it because it's there. You're not going to recreate the whole mathematical, it's no point. So I see it as like maybe 30% of your features come from the feature store, but 70% you're still doing it on your own, generally. Yeah. Cool. Other questions? No more? Yes? One more. Yes. Yeah. Right. It does exist, but it's very nascent. So companies like Google probably had it way back, right, internally. I'm sure they had it way back. Companies like Uber just started building it 3-4 years ago because the necessity was there. But it doesn't exist at a very scaled, it's not like Jira or Confluence is right now, right, or Salesforce is right now with CRM. Like it's not at that sort of scaled, professional, like shiny sheen on it kind of layer. And what does exist in an open source level is still very much focused on sort of PhD data science use cases rather than business use cases. And it's not just pushing models into production, it is the entire life cycle. It starts from experimentation and visualization, right? Like if I plug in some sort of data into the system, I want to be able to visualize my data and see how the data is skewed or whether I need to change the weights up a little. That kind of stuff, end to end, it's starting to be built. Like SageMaker is a good example, but it's not as, Amazon SageMaker. It's not as robust as it could be, and there's still a lot of opportunity for nimble startups to come in and say, hey, we're going to offer this as a service. Like I think Databricks is doing that too, but I don't really know what Databricks does right now, so might be wrong on that. But yeah, yes. hardware thing, I don't know anything about hardware, man. Like, I just know that it works, and when I pull my data and it works, I'm happy. And if it doesn't, I call up the hardware guy. Like, yo, is the data center down? You know, yeah. Oh, there we go. Next week has your answer, so stay tuned. Yes. Yeah, I'm sure that if, for example, Google, whatever they're using for their Google Home, that natural language processing system probably has tens, maybe hundreds of models in production to do everything from figuring out your accent to figuring out what you actually mean to say when you say a word. Those are all models. Reading comprehension, yeah, I'm sure. Like, and the question is whether this applies to NLP. Yeah, this applies to anything in the whole machine learning or data science domain. Yeah, yeah, yeah. Cool. Thank you very much, guys. Really appreciate it. And quick note: there is a hackathon happening in SF, hosted by Galvanize, which I'll be judging on. If you don't mind me plugging it, by the way. So essentially, in November 3rd and 4th, there is going to be a hackathon for people who are business people to be paired with engineers, and they create something. It's called AI for Good, essentially, the ethics of AI. Building out systems that promote AI for good stuff. And I'll be giving a keynote speech next Sunday around that too, if you guys are interested. It's going to be in SF, and just ping me if you want details on it. Thank you.
So that was absolutely wonderful. Thank you very much for taking the time and for kind of giving us this bonus lecture on model management. Yes, I thank you very much. And Vishnu, on behalf of Hacker Dojo, we would like to give you this souvenir. And again, the big thing about this souvenir, it is all made over here. Yes, only the wood is from Home Depot, but everything, right from the engraving and everything, has been done in the laser cutting machine over there. Yes, it's a homemade. Yes, absolutely. And yeah. Okay. Thank you so much. Thank you very much. Thanks a lot for coming. Okay. Hey. And folks, two announcements to make. One is there is a conference, AI conference on 9th and 10th of November at the San Jose Convention Center. It is called AI Frontiers. And I think one of the person you mentioned, Ilya Sukstiver. Yeah, so he's one of the main speakers over there, and one can say that he is one of the fathers of deep learning, founding fathers of deep learning, along with Jeffrey Hinton and things like that. But the other speakers are also equally good. They're people from Google and Microsoft. And so again, if in case anybody is interested in this conference in San Jose Convention Center, I have a code that will give you a 35% discount. It is P as in Peter, 35 T stud, okay? P as in Peter, 35 T stud. It is for AI conference that is on November 9th and 10th at San Jose Convention Center. I looked at the speakers, and all the speakers are absolutely fabulous speakers, okay? So I think if in case you are interested in going deeper, that would be the conference to go to.